Okay, we will now begin to do our coverage of the welding processes, and we can go back, and I think we can go back here. There we go. Showing what we're going to be covering, an overview of the welding technology, the actual weld joint, the physics of welding, and finally the features of a fusion welded joint. So we will proceed with that. And so basically what we're talking about here in this welding process is obviously joining two pieces of traditionally metals that are, the expression is coalesced at their contacting surfaces. And we'll define what those contacting surfaces are here in a minute. And we're going to do this by either some sort of application of high temperature heat and or sometimes even pressure. So many of the processes are either accomplished by heat alone or with no pressure applied, of course, and that's what we normally are using, is just a high heat concentration and focused heat in what we call fusion welding. But at any rate, so a lot of times in these fusion welding processes, we are going to use a filler material to help facilitate the coalescence of that joint and to give it a little more structure to it. All right. Now, we know why welding is important. There's a lot of applications, and of course, most of the time, if you know what you're doing, it's going to give you a permanent joint. So it's not something that you're going to be able to take loose and maintain or change its structure. So it's going to usually be obviously a permanent type of a joint. And welding can also be accomplished in the field. So it's not just necessarily in some kind of traditional manufacturing indoors environment. Okay, of course there are some limitations and drawbacks for welding, and one of the ones that you have to be aware of is, first of all, it has to be done by a qualified person, a qualified welder, to make that structural integrity of that welded joint perform the way it's supposed to be. Now, what's hidden in a lot of these is quality defects, and of course that can be very difficult to detect, being that the defect would actually be inside of that fused welded heat affected zone right there. So that's something definitely to be concerned about. Now again, we're identifying these surfaces, the two surfaces that are going to be welded together. It's called Faying surfaces. Okay, and most of the times, of course, we're going to be using metals that are of the same composition, but frequently, sometimes it's required that we obviously do dissimilar metals. And from a general overall standpoint, there's really only one process that's qualified to weld dissimilar materials, and that would be a tungsten inert gas, aka TIG welding. So we'll talk about that process a little bit later. All right, so of course there are all different types of processes, and this is the professional organization, the American Welding Society. They have organized the standards and the characteristics and qualifications for these processes, and it's an excellent society. In fact, they have a nice student chapter that you can join, and you'd get a lot of really good information out of that. Okay, so again, as I told you before, there's basically two types of categories of welding. There's a fusion welding, which we're most familiar with. We're actually melting the metals together, and then there's solid state welding. So fusion welding, again, is just melting the base materials together. And then fusion welding can be divided into these categories. There's arc welding, which is what we're most familiar with, accomplished by an electric arc. Then the resistance welding, Basically just heat resistance and electrical current between the two surfaces. We'll show examples of that later. And then there's oxy-fuel gas welding, which is rarely done, but it can be done. And solid state welding, basically what we're talking about is not necessarily melting the temperatures together. We are going to be using heat, but lion's share of the force will be applied, or the force will be a pressure. So we're going to combine both a pressure along with some sort of added heat. So, but usually in that solid state welding process, which we'll give some examples later, there are no filler metals that are added to this. So here are the processes. There's something called diffusion welding, which you remember what diffusion is all about from your days of material science, of course. Then there's friction welding and friction stir welding, and then also there's ultrasonic welding. And of course, here's just some principal applications, and I've listed most of the major ones here, including upcycled steel transformations. So the welded joint, there's two issues about the weld joints. First of all, there's the type of joint that is to be welded or designed. And then there's also the types of welds used to join these pieces that form these joints. Okay, so there's two different separate items or issues regarding weldments. And that's what we usually call a site where we have welded two pieces together, coalesced together. We usually just call it a weldment. All right, so here are the 5 types of joints, as you can see listed here. A butt joint here, an obvious corner joint, a lap joint, a T-joint, and an edge joint. Now, unfortunately, you're going to get a chance to experience these types of joints, most of them in your lab, but of course, that has all changed, and at some point, maybe if you're still around next fall, maybe we can evoke some sort of a makeup welding lab for those that did not get it. So at any rate, we'll see what happens. So the types of welds. Each of those joints that we just looked at, geometry-wise, can be joined using a wide variety of welding types. And so there is, obviously, we've pointed out now, a difference between the joint type and the way it is welded, or the weld type. So just remember that. And the first and most obvious of the type of weld is called a fillet weld, and used to fill the edges, obviously, between plates created at some sort of corner, lap, or T-joints. And it's very common, and it's most common in arc and oxy-fuel welding, and requires minimum edge preparation. But trust me, all weldment joints require edge preparation. That's something you do not want to neglect. And so here are some examples of these fillet welds at the different types of joints here. Here's a nice single fillet at a corner. Here is the outside single fillet. Here's a double on a lap. And then here's a T-joint on both sides. And we'll look at this geometry right here in detail a little bit later on. Okay, so here's basically plug and slot welds. You just punch a hole in here or punch a slot in here and just fill this up. And you can't see it from this back side. It makes a nice clean joint if doing it this way. All right, so this is the physics of welding. Fusion, again, is the most common means. And so what we're doing is very, very high temperatures in a very localized area that we're melting the base metals and trying to do it with as least amount of energy as possible, but still get the desired results of the two base metals melting together. So here's this typical fusion welded joint, and this is what we were talking about here. Here's the actual fusion zone where the melt occurred. This is the actual interface right here where it basically stopped. And this area all around here is called the heat affected zone, or HAZ. All right, now that's the area where there's really a lot of issues with respect to defects, right around this heat affected zone, because as you can well imagine, the metallurgical properties have obviously changed from a room temperature metal alloy to very quickly up to a melting temperature, and then slowly or actually rapidly cooled. And so there's all kinds of changes going on with respect to the lattice structures within the grains when that kind of heat and quenching is taking place. So there's a lot of metallurgical issues associated with this heat affected zone. And this is kind of what the grain structure looks like around that heat affected zone. All right, now folks, I'm kind of running out of time on this because they don't want me to do any more than 10 to 15 minutes, so I'm right at 11 minutes right now. So I'll continue to go through this, but I'll have to probably finish this off here in a second or two, or a minute or two. Okay, so these are the features as we showed you: the fusion zone, the heat affected zone. That's why this is in red, because it's very, very important. And also, we just explained a moment ago, the composition changes all around that. And so that definitely affects the mechanical properties in the heat affected zone. And usually, as this says, is usually negatively speaking. And I wrote this in all red because that's true. That's where most of the welding failures occur, will be in this heat affected zone. All right. Now, apparently, that was it. That's good. Okay, so I'm going to stop this, and we'll see you on the next one.